As I said, we've got today to look at whatever you're interested in. And then Thursday is a break. And then 1 week from today, we review, we'll have another day of review on chapter 10. I've got that review in there. So any questions from that? And then on the 4th, our test on Zoom, okay? Any questions? Y'all okay? All right, let's see what we can get into then. Okay, see this one up here, number 29. Anybody got any ideas on how we could deal with something like this? If the odds against a horse race are 9 to 5, find the probability that the horse will win the race.
No.
All right. What can we do? So would y'all taking the break early? Come on. What can we do to figure out what number 29 wants? Hi, Naomi. All right. So they're giving us some information here. What do we got? That's the only thing we've got. That's the only thing that they're giving us. How can we find the probability that, of the horse winning the race? And they also tell us this is odds against. So let me kind of refresh memory here. B to A. All right. So in this case, A is equal to 9. I'm sorry, A is equal to 5. And B is equal to 9. All right. So we've got that information. So we're off to the races. What we're going to do is fill in. And since we want the probability of when, then what we've got is A over A plus B. If we've got odds, then we can create probabilities as such. For the probability of A or when, whatever, then we can use the A and B to create that. If we want the probability that the horse will lose the race, then we're finding the complement. But this can be easily put together as so the probability that the horse will win the race is 5 nines. I'm sorry, 5 14ths. Okay. Any questions about that? Are y'all sure y'all hearing me?
Yeah.
All right. I
Yes.
was trying to wake y'all up. I know that we're getting on a break and I'm looking forward to, but just remember this chapter 10 is a big test. It's got a lot of stuff in it. All right. So y'all help get me going here because I'm in the same shape as y'all. I'd like to be out of here too. Okay.
So when the odds are against you, add.
No. What are you talking about adding? Try to break that down and explain what you're asking because
We have, you could do the A over A plus B and then the A over A minus B. How do you know when you add?
no. There's no plus. There's no negative. There's no A minus B. Let me show
Oh.
you the other part of this. So the complement or the probability of not winning the race is going to be B over A plus B. You always add up because in this case, they don't ask this. This is the one that they're asking for, but I'm just going to show you that everything. All right. So this would be 9 over 14. What do you notice about these two, the denominator of these two? They're both 14, right? And that's the way probabilities work. The probability of winning is 5 over 14. The probability of not winning is 9 over 14, because, and the way we can get this is using the complement rule, or you use my easy way of 5 from 14 gives you 9, and you keep that same denominator. You see, 5 plus 9 is 14, and that determines the denominator for any of the probabilities. Either one of the probabilities, to be more specific.
All right, thank you. I don't know why I
Mhm.
thought it subtracted, but you answered my
Yeah,
question.
well, there are certain things in math where you might have to do that, so I can understand that. You might have seen it somewhere else. But in this case, when you're talking about probabilities, you always take the two numbers in the odds and add them up to get the denominator. That's for no matter what the probability is, whether it's win or lose, win or not win. 5 plus 9 is 14. The only thing that's different is the denominator. The denominator has to be the A. And since we had odds against, that means the A was second, okay? That's why A is 5. And then the first one in odds against is the B. All right, let's see what else we can get into. Well, that's a good question. All right. Okay, so here we've got one that looks interesting. Number 25. And I tell you what, I'm going to put this up here. I'm going to kind of put these up here. So the probability of A, I'm just going to use A. All right. So what we do. Oh, you know what? I got to find the probability. This doesn't have the probability. Let's see. I tell you what, I'm going to try a different one. I don't feel like messing with that one. Let's just do this one here. Well, that's the one I wanted to do anyway. I don't know how I got back up to 24. Anyway, so the probability of A is going to be finding out for each one of these what the probability is. And so we got a 52 card deck. Sally's going to draw one. And in order to find the odds, we really need to have the probability first. In other words, we got to have the probability of the queen to do that first one. All right. And that's the equivalent of probability of A. All right. So what's the probability of a queen? Do y'all remember? I got the thing here.
4.
So what's the probability of a queen?
4 over 52.
4 over 52. And we can simplify that down to, so there's your 4, 52 total. So we can simplify that down to, so it's 113. So for every 13 cards, every suit of 13 cards, there's 4 of them. There's one queen. All right. Now, the probability of the queen is 113. So what's the probability of no queen? It's the complement or you can use my like easy way. 1 from 13 gives us 12. Keep that same denominator. All right. So we got those numerators now. A is equal to 1. B is equal to 12. See where I'm getting those from? It's the numerators of the probability of a queen and the probability of no queen. Okay. Any questions on how I got those? Okay. So then simply for this one here, then we've got 1 to 12. So for every one of these, we got to calculate the probability. I'm going to kind of do skip one and do this one, getting a club. What's the probability of a club? Probability of a club. There's 13 clubs over 52. And that simplifies down to 1/4. You always want to work with these simplified fractions and simplify the fractions of the probabilities before you build the odds. All right. So what's the probability of no club? Well, it's 3/4. I'll write it in. Okay, questions on how we got those? A is equal to 1, B is equal to 3. And so now we can do our odds against. Now, odds against is turned around. It's B to A. I think I had this up here before. Let's see. Odds for is A to B. Odds against is B to A. Just turn them around. So the odds against getting a club are
3 to 1.
put it over here. 3 to 1. Good. Thank you. Very good. And now, what do you notice about this, about the 3 and the 1? How does that relate to the denominator of each of these? The
If you
two
add
parts.
equal 4.
Yeah, if you add them up, it's equal to the denominator. So when you got odds, you take the two numbers and you add them up, and that's going to be the denominator to get back to your probability. And that's the one we did earlier, the first one. Okay. All right. Let's do this one. Another in favor. So that's going to be A to B. Okay. A to B. So what we got to have first is the probabilities of getting a black card and the probability of not getting a black card. So the probability of a black card is equal to 1/2, right?
Yeah.
Half the deck is black. So 26 over 52 gives us 1/2. So the probability of not black is also going to be 1/2. Because 1 from 2 gives us 1. So then our odds in favor of getting a black card are 1 to 1. So 1 to 1 just means it's even, what somebody might call even odds, because half the deck is white. I mean, half the deck is red and half the deck is black. All right. All right, let me go over to Alex and use one of the, get a problem from over there in one of the assignments. I don't really like any ones in the book for the, I think we already did them, the ones that are in here, but like the second part of 10.6 involves actually, I don't think we did this one. Maybe we can try this one. All right. So maybe just kind of give you an idea of what expectation is, or expected value. Expected value is what we can expect to happen over the long run. In other words, for everybody that plays the game, on the average, we can expect to reap that amount on each play of the game, or whatever it is we're looking at. It doesn't have to be a game, but it can be. There's some things in there with insurance and stuff. You may have run across them if you got that far yet. All right. I'm going to have to find a nice white surface to do this, because you really need a chart. Some of them are a little bit easier. You don't need a chart, but most of them you're going to do. All right. I think we already did this one. We did that one. So that's not the one I want to do. I know which one I'm going to do. I guess we could do this one. I got one I can go over and get in Alex, but all right. We're still going to have to go over and find a chart. I mean, find a place to do a chart. All right. So let's go over here. All right. So I'm going to make a little chart. Not all of them it's necessary, but it does help. So X is what we call the outcome. What happens when we do that particular thing? And probability of X is how likely it is to happen. All right. So what was the first thing? Belinda buys one raffle ticket at the Spring Fling. Since there is a $1,000 prize, a $500,000 prize, and a $100 prize. All right. So 100, 500, 100. So we got 1,000. All right. Little that line. And it's 500, was it? So 500 and 100. So this is going to be 500. Okay. And 100. And then that's the only 3 prizes. And then lose. So 3 winners and 1 loser. All right. Now, here's where we got to watch out, because if Melinda buys 1 raffle ticket at the spring fling and then she wins the $1,000 prize, how much is she actually winning? She's not winning the full $1,000 because she paid $3 to get in. All right. And so that's going to be the same for all of those. The $3 has got to be put in there. All right. So this is going to be 1,000 minus, so that's 997, right?
Yes.
Okay. So this one would be 497. This one will be 197. And this one is just going to be -3. Because whether you win or lose, that -3 is being calculated there. So the -3 from 1,000 gives you 997. -3 from 500 gives you 497. -3 from 1,000, it's 100. So that should be 97. Let me fix that. 97. I got a problem in my notes and it's got a 200. So that's why I was thinking about that one. All right. Now let's go back over and we're going to figure out the probabilities of each one of these. All right. So there are 1,000 tickets sold at $3 each. We've already used the $3, but the 1,000 is where we gotta figure out our probabilities from. So how many, or what's the probability of winning this one? Well, it's 1 over 1,000, right? If there are 1,000 tickets sold. Same thing with this. 1,000 tickets. Only one of them is the $500 prize. Likewise, only one of them is the $100 prize. And so the probability of getting the $1,000 ticket is 1 over 1,000. The probability to get the $500 ticket is 1 over 1,000. The probability of getting the $100 ticket is 1 over 1,000. Now, there's only those 3 tickets, right? What about, how many do we have that are not winners? $1,000 minus 3. I believe that's 997. And that's over 1,000. Does that look good? I heard somebody starting to talk. So if you were telling me something important. So 1 over 1,000, 1 over 1,000, 1 over 1,000, 997 over 1,000. All right, now what we do is we multiply. Now you can put this in here to kind of match the formula, but it's just x times p of x. All right, so I'm just going to multiply the outcome times the probability. Now, I'm going to show you on this one kind of over here just to show you what's happening. But we got 997, and that's a whole number. It's over 1. And we're multiplying it times 1 over 1,000. We're not going to simplify anything yet. So we're just going to multiply across. Remember, for fractions, numerators multiply each other, denominators multiply each other. So this is 997 over 1,000. This one's going to be the same thing, except it's 497 over 1,000. This one's 997 over 1,000. So now, and I'm going to do it over here on the side. -3, and that's over 1. It's a whole number, times the 997 over 1,000. All right, so what is that? That's 997 times 3, 2,091. Let me double check. So 2,991. And it's negative. Now, I didn't simplify anything, and for good reason, because it's going to make the math easier. This will be the same thing for section 10.7, where you got the OR, which is the adding. Don't simplify your fractions right off the bat. You wait until you get one final value, and then you simplify it. In 10.8, when you're multiplying, you simplify them first, and then that'll make your life a whole lot easier, because then you won't have to do a whole lot of simplifying at the end. All right, so now these three right here are positive. The thing on the ones on the left. Okay. So 997 plus 497 plus 97 is equal to 1591. So I'm adding all these up. So that's a plus, and then this one is minus. So my fraction is all over 1,000. See, since it's all the same denominator, to add those fractions, we just place them over that common denominator. Now, up here at the top, the first three ones add up to 1591, and I'm subtracting 2991. All right, because that's the only one that's negative. These three were positive. So that is going to be equal to, and let me put another little fraction bar. So 1591, I'm going to subtract the 1591 and or subtract the 29.91 from the 15.91. So that's negative 1,400 over 1,000. And now we can simplify that by taking why did it like, there we go. I don't want to really, all this want to release these. Why in the world is it like that? I guess it goes by grid or something. All right. So now I'm going to take the 1,400 negative and divide it by 1,000. That's what a fraction means. It means divide. So that's the expected value. Negative $1.40. So what does that mean? Because there's no way to win $1.40, or there's no way to lose $1.40. You're gonna lose $3 regardless, because you're paying $3 to play. And then you could possibly win the $9.97, $4.97, and $97. But here's what the expected value means. So this means that the 1,000 tickets sold, there will be, I'll put it like this, each player pays $1.40 to play. That's what it means. After the prizes are paid out, and they're going to have to pay out, what is it, $1,600. They still are going to, on the average, have just a little bit less than half of what they paid to actually play. So on the average, each player is paying $1.40. Not any one, but all of them together on the average. All right, questions? All right, take a gander at that one.
No.
Finished.
Those are the long ones that there seem to be easier in my opinion.
Yeah, they are long. Because it's just a matter of, you gotta take into account all of those things. You gotta take into account how much you're paying. You gotta take into account how much you're actually getting, and you gotta take into account what the probability is for each one. And like I said, it's really, really hard sometimes to grasp what that means, that $1.40, and it's negative $1.40, because that means for the player, they're paying $1.40 on average. No one player is going to be getting $1. It's just paying $1.40. They're either paying $3, and 3 lucky people are going to get $9.97, $4.97, and $97. But on the average, this is what the house, whoever this is, if it's a church or benefit, they can expect that each one of those 1,000 people for each ticket will pay $1.40. So that means that they're coming out with, I don't know if they'll ask you this, but let's say they might ask you this in Alex. So that means 1.4 times that. So they're making about $1,400 overall, would be after they pay out the tickets. Because if you add the 1,600 back, So you get the 3,000, which is the 3 times $3, dollars. 1,000 times $3. So it's a little bit over half is for prizes. All right. Let's see what else we can get to. Because what I got in that little thing here, I may just start it for you early. I think I had it going at 6:25 or something. But it should be, it's fairly short. And I'm putting it at the end of the class just so, you know, I know that some people are. Let's see here. All right, so it'll be available now until the end of class. If you got any questions, believe me, I'll be glad to go over it, but otherwise you can go to it and work, okay? So it should be there beginning at 6:12.